At NASA's Michoud Assembly Facility, work is underway on the Orion spacecraft's monstrous rocket booster system. Pat Whips is tasked with building the propulsion system that will send Orion on 2 test missions beyond low Earth orbit.
The Space Launch System rocket will be the most powerful rocket that's ever left the face of the Earth.
Orion's solid rocket boosters will generate over 75% of its thrust, enabling the spacecraft to carry a payload of almost 80 tons. The rocket's core stage is a giant fuel tank. It will store the cryogenic liquid hydrogen and liquid oxygen used to power Orion's 4 RS-25 engines. RS-25 engines were first used during the Space Shuttle program.
The engineering that's gone into these engines is just incredible. I call them the Mona Lisa of mechanical engineering.
Steve Wofford heads up the team testing the Space Launch System's engines at the Stennis Rocket Facility in Mississippi.
To be able to do what they do with the efficiency that they do and harness that incredible amount of energy and produce the power that they do, it just astonishes me. I've been in love with these engines for over 25 years now.
These colossal engines are paired with 2 gigantic 150-foot rocket boosters. In March 2015, tests begin in the Utah desert. During the 2-minute burn, engineers collect data on 103 design objectives. The world's largest solid rocket motor generates a jaw-dropping 3.6 million pounds of thrust, the equivalent of 14 jumbo jets at maximum power.
These engines will get to orbital velocity of 17,500 miles per hour, which is about Mach 25.
For Orion's 100 million-mile journey to Mars, NASA engineers are building an even more powerful version of this rocket system.
In just a few more years down the road, our 130 metric ton version of the Space Launch System will be able to take nearly 140 tons of payload, ultimately taking habitats and equipment and, of course, astronauts to the surface of Mars.